AI Agentic Planning: How Senior Engineers Build Goal-Driven, Multi-Step AI Systems in Production. Welcome to Agentic AI World, your daily interview prep for senior AI and machine learning engineering roles. I'm your host, and today we're tackling episode 59, AI Agentic Planning: How Senior Engineers Build Goal-Driven, Multi-Step AI Systems in Production. If you're interviewing for a senior AI engineer role in 2025 or 2026, you will get a question about agentic AI. Not maybe, you will. Companies are pouring resources into autonomous AI systems, and they need engineers who understand how these systems actually work under the hood. Let's break it down. Part 1. What is agentic planning? An AI agent isn't just a chatbot that answers questions. An agent has a goal, and it figures out on its own how to achieve that goal, step by step, using tools, calling APIs, checking its own output, and adapting when things go wrong. Agentic planning is the brain behind this process. It's the mechanism that takes a high-level objective, say, research this company and book a meeting with their CEO, and breaks it down into a sequence of executable steps. There are 3 core planning paradigms you must know for interviews. 1. React, short for reason plus act. The agent interleaves reasoning steps with action steps. It thinks out loud, takes an action, observes the result, and reasons again. This is the most widely used pattern today. Think of it as a while loop with thought-action-observation cycles. 2. Plan and execute. The agent first creates a complete plan, a list of steps, and then executes them one by one. The planning phase uses a powerful model. Execution phases can use cheaper, faster models. This is great for deterministic, predictable workflows. 3. Tree of thoughts, or TOT. The agent explores multiple reasoning paths simultaneously, like a tree branching out, and scores each path to find the best one. This is computationally expensive but powerful for complex problems with many possible solutions. Part 2. The interview question you'll face. Here's a real question I've seen at top-tier companies. Design an AI agent system that can autonomously perform customer onboarding, pulling data from CRM, verifying identity via a third-party API, setting up accounts, and sending welcome emails. Walk me through the architecture. This question tests 3 things: your ability to decompose a goal into a plan, your knowledge of agent tool integration, and your understanding of failure modes. Let's walk through the model answer. The system has 4 layers. Layer 1 is the planner. This is a large language model, typically GPT, for class or equivalent, whose job is to take the goal and produce an ordered list of subtasks. The planner uses few-shot prompting with examples of good plans. It outputs structured JSON, not free text, because you need to parse and execute each step reliably. Layer 2 is the tool registry. This is a catalog of every capability the agent has: CRM lookup, identity verification API, database write, email send. Each tool has a schema, name, description, input format, output format. The planner calls tools by name. The executor calls them by code. You want this decoupled so you can add tools without retraining or reprompting. Layer 3 is the executor. This is the runtime that actually calls tools, handles retries, manages timeouts, and passes results back to the planner or the next step in the chain. In production, this is where you need circuit breakers. If identity verification is down, you don't want the agent to spin in a retry loop burning tokens and API credits. Layer 4 is the state manager. Agents fail. Networks fail. APIs return errors. You need durable state so the agent can resume from where it left off. In practice, this means storing every step's input and output in a persistent store, Redis, Postgres, or a purpose-built workflow engine like Temporal or Prefect. If the agent dies mid-execution, you replay from the last successful checkpoint, not from the beginning. Part 3. The failures that kill production agents. This is what separates junior answers from senior answers. Knowing the architecture is table stakes. Knowing what breaks it and how to fix it gets you the offer. Failure 1. Hallucinated tool calls. The LLM sometimes invents tool names or parameters that don't exist. Mitigation. Strict JSON schema validation at the executor layer. If the tool call doesn't match the registry, reject it and send the error back to the planner for self-correction. Failure 2. Infinite loops. An agent that can't complete a step will sometimes keep retrying indefinitely. Mitigation, max step budgets. Every agent run has a hard cap on the number of LLM calls, tool calls, and wall clock time. When the budget is exhausted, the agent escalates to a human or fails gracefully. Failure 3. Context overflow. In long multi-step workflows, the conversation history grows until it exceeds the model's context window and quality degrades. Mitigation, rolling context compression. Summarize earlier steps before appending new ones. Keep only the plan, the current step, and the last N observations in the active context. Failure 4. Non-idempotent actions. If your agent sends a welcome email and then crashes, you don't want it to send a second email on retry. Mitigation, idempotency keys. Every action that has side effects, email, payment, database write, must include a unique key. The downstream system checks the key and ignores duplicate requests. Part 4. Production patterns worth knowing. 3 patterns that come up in senior interviews. Pattern 1. Human-in-the-loop escalation. Not all decisions should be fully autonomous. Design your agents with confidence thresholds. If the agent's next action has a confidence score below a threshold, say 0.7, it pauses and routes to a human for approval. This is how you deploy safely in regulated industries like finance and healthcare. Pattern 2. Parallel subagent execution. For independent subtasks, spawn multiple subagents concurrently and join their results. This cuts end-to-end latency dramatically. The challenge is dependency tracking. You need a lightweight DAG or directed acyclic graph to know which tasks can run in parallel and which must wait. Pattern 3. Reflection and self-critique. After completing a plan, the agent reviews its own output against the original goal. This is a second LLM call, cheap relative to the cost of a bad outcome. It catches obvious failures like incomplete steps or contradictory results before you surface them to the user. Part 5. Your 2-minute interview answer. When an interviewer asks, "How would you build an agentic planning system?" Here's your structure. Start with the goal decomposition. I'd use a planner LLM to break the high-level goal into structured, executable subtasks with a JSON output schema. Move to tool integration. Each tool is registered with a name, description, and input-output schema. The planner selects tools. The executor runs them. Address failure modes. I'd add idempotency keys for side-affecting actions, a max step budget to prevent infinite loops, and rolling context compression to handle long workflows. Close with reliability. For production, I'd use a workflow orchestrator for durable state and human-in-the-loop escalation for low-confidence decisions. For beats, 30 seconds each. You've just answered at the senior level. Wrapping up, today's key takeaways. Know the 3 planning paradigms: react, plan and execute, and tree of thoughts. Build agentic systems with 4 layers: planner, tool registry, executor, and state manager. The production killers are hallucinated tool calls, infinite loops, context overflow, and non-idempotent actions, and you now know how to mitigate each one. Use human-in-the-loop, parallel subagents, and reflection as your 3 production-grade patterns. That's episode 59 of Agentic AI World. If this helped you, subscribe and hit the bell. A new episode drops every day. Share it with a friend who's interviewing for AI roles. And I'll see you tomorrow.